Welcome to Figment Part 2, where we'll show how we can use Figment to train a machine learning algorithm from scratch. So in this case, what we're going to use is this system called Pix2Pix. This is an algorithm that's a bit older, but it's super useful because it allows us full control over the input that we want to do. Pix2Pix is made because it's what's called a conditional generative adversarial network. So these are basically networks that are trained to have an input image and an output image. And the goal is to have an input that resembles the output. So the goal of a conditional generative adversarial network is to generate an output that resembles the input as much as possible. Now, this input can be anything. For example, in this case, the input is a black and white image and the output is a color image. The way that we train these algorithms, however, is to do it the opposite way around. So we give it a bunch of color images that are already in color. We remove the color, we desaturate them, and then we train a machine learning algorithm showing just a black and white image and having it calculate or get as close as possible to the color image. So next time that we have a black and white image where we don't have a color version of it, we are going to use this information that the machine learning algorithm has learned to generate new color information. Now, this color information will obviously be fake. We don't know if it's going to be right or not. Again, the original information, for example, from this image is lost, but we can do this by context because we know that these other images already have colors. There's other things that we can do as well. For example, this is this fill in the blanks algorithm where we remove a part of the image and then let the AI calculate it. And again, it's easy. Like we can have the original image, put a white square on the thing that we want to remove, and then have it learn in reverse. So basically having to figure out which part goes in here. This is another example. So we have a bunch of cats that we want to generate, and then we have these segmentations of cats, so basically a drawing of a cat, and then we want this to be generated into a photorealistic version of a cat. And we train it in reverse. So we give it a cat, we calculate how a segmentation, so a drawing of that cat could look like, and then we give this to the machine learning algorithm, and then we ask it, okay, now generate a photorealistic cat. And we're sort of monitoring this progress as it goes, making it better and better and better. So that's what we're going to make. In this case, what we're going to do is just use our face because that's going to be easy. So we'll use the webcam to get some input data because it's just there, it's available. So that's going to be easy. So instead of load movie, what we're going to do in Figment is to double click and then select the webcam node. So that will return a webcam stream. So this is me. This is set to a frame rate of 30, which is perfect. And what Pix2Pix requires is it requires an image of 1024 by 512. So 1024 because it's actually two images side by side, and 512, that's the height. Now this resize node is actually set up correctly for that. So it's 512 by 512. And so if we turn this webcam image into the resize node, we can see this gives an image of 512 by 512. Now we want to do something with the image, right? So we want to get some input from this image in order to figure out, okay, what's the source image? What's the control image? What do we train on? We can use levels here like we did before to remove saturation from this image, but we want to do something else. So in this case, what we want to do is we want to use a face detect node, so detect faces, or put this in and then take the output of resize and turn that into detect faces. And this will detect our face, as you can see here. So as I move around, you can see it actually detects my face. Pretty cool. There's a bunch of ways that we can detect a face. So this draws the contours, as you can see here. We can also draw the tessellation, remove the contours. So that draws like a full-on, very detailed version of the face. And then we can also draw this bounding box, which has almost zero information. With these machine learning things, it's always interesting to consider how much information we give to the AI and how much we leave out. So in this case, for example, we leave out a nose, which might have an effect on the machine learning as it's trying to figure out where a nose could be. All right, so now we place these two images side by side. We already have this stack node here set up for us, so that's going to be easy. We place these here side by side. And so now we have an image that's 1024 because these are two images side by side by 512. We have our out node here, and then probably if you've set this up from the beginning, we don't have a save image yet, so we'll create one together. We're going to double click save image, and then take the output here and put it in. All right. So in my save image node, this is my final node. I'm going to say the template is going to be set to JPEG like this. Press enter in order to make sure that this is saved. And then I want to save this out as an export folder. Now I actually recorded this twice because before my export folder actually already contained images, and some of them were overwritten, but not all of them. So what I want to do is just make sure that this export folder either is empty by selecting all the files and deleting them, or just deleting the folder and making a new one called export. So here I'm going to do file, render, and I want to set the frame rate to 30 because that's the frame rate of my camera. And I want a bunch of frames, so let's say 500. That's a bunch of number of seconds of data that we want to record. And here it's important, once I start recording, that I do as much variation in my face as possible, because the more variation I have, the more the system will generalize on my face. So if I just stay still all the time, that's the only thing I have seen. So I would do as much movement as possible, and you'll see that as I speed up the video. So let's go. All right, so we now have our frames. Let's go to our export folder and look at them. So these look good. These look less good, but whatever. We can also select from our dataset if we really want to, but these are just for trial. All right, and now comes the part where we actually use machine learning. So we can quit Figment here. We can open Firefox, and then this is the URL. I'll put this in the description. This is for the latest workshop we're now doing, but all of them sort of look the same. And we're going to use Google Colab to train. So I'm going to go to Google Colab here. So colab.research.google.com. And then here I will choose GitHub, and I will paste the link that I have here. I think I can just paste the whole link here in. And what Google will do now, or what Colab will do, is look at this. I have to press enter, I think. Look at this and then see which files are actually available from the Watch Out workshop. This is not what I expected actually, so I think it did something wrong, because the repository here is linked to a different one, because I want to link it to this one. Okay, now we're here. So make sure that this is set to the repository that we want. We also have a bunch of other ones. They all actually work, but it's nice to use the latest one. Let's select training Colab and then pix to pix, train Colab. The other one, so these ones are for training locally, so if you're on your own machine. This one is one we have to run later, so we just are interested in this one. So click it. That's going to open it as our own Colab thing that we can change, and now we can run all the cells in this to get the data. First, of course, we have to make sure that the data is actually stored on the dataset. So we're going to make this into a zip file, compress it. This is called export.zip. And then in Colab, okay, so we are gonna run one cell first. So let's run this cell to have a machine start. So it says this was not made by Google, that's right. And then we do run anyway. This would normally tell us that we are connected to a Colab with a GPU, which is cool. All right, we have one here. And now we can click here. This will show us the files that we have, and we can drag our export in here. Yeah, it says it's not going to be saved, but that's fine. And then while that's uploading, we can run through these cells and see what they do. So we import some things here. We check if we actually get GPU support. If it says not available, it's not a good idea because it will run really slowly. These are some tweakable parameters that we set. The buffer size, I normally leave this empty. The batch size sort of depends on the video card that you're using. If it gives like out of memory errors, OOM errors, you would decrease the batch size. I think I can increase it here, but I'll stay it like this. The image width and height is set to the size that we have exported. Note that these are for singular images. We have these double images, but this is for just one single image. And then we're going to lock the seed, so the random seed, in order to avoid that there is too much randomness here. If you wouldn't have a data set yet, we can use this one, which is a prepared data set, but now we already have one. So we're just going to use this one. We're going to make a folder called datasets, and then we're going to unzip that into that folder. But first we have to wait until this export.zip has been uploaded. So I'll cut this part out of the video, and then you can see once it's done. We have our export here, so our export file has been uploaded, and then we can run this cell. And so what this is going to do is make a datasets folder, unzip this into the datasets folder, and then remove some crap that's there. So if we refresh, we should see this folder called datasets, face, and then inside we would have all our files. Cool. This is just to make sure that we have directories that should exist. And then here, this is set to look for the dataset in datasets.face. So if you called it differently here, it would be different here. But if these are all the defaults, you can save. Look at like this. This is important though. If you've saved this as PNG files, you would also use PNGs here. I'm using JPEGs, so this should work. And then I can show an example image from the dataset. So by pressing this cell, and if all goes well, I have this beautiful image of myself here. This is better. So now we can build what's called a pipeline. So this is how the data goes through. We load the image, we normalize them basically from values from -1 to 1 instead of from 0 to 255. We resize them, we randomly crop them, we jitter them, as it's called. So we sort of move things around a little bit. And then we have this process image that does all these steps for us. We can show an example and you can see sort of what that looks like. So this is a image, and then here if we do it again, do we see a different one? No, this is always going to get the same one, but maybe we can see that it sort of shifts a little bit every time. That's what we want to see. So that's actually learning not just the default version where I'm sitting still, but it's actually showing the version where I move a little bit because it can do that. We build a training data set, and then we can show that that works as well. So it's basically all showing that everything is well and that we're actually having these inputs and outputs connected. Beautiful. So now we can create the generator. So Pix2Pix network consists of a generator and a discriminator. So this is the generator. It generates new images. And the way that it does that is it basically starts from an input that's a big size, scales it down, and scales it back up. This is called a U-net because it sort of looks like a U, like this. And then what you can look at the output immediately of the generator, and what it will show is that this is just noise because the generator is now initialized, but it doesn't have any data yet, so it doesn't know what it would generate. There's no data connected to it, and that's normal because this is just initialized with random values. In machine learning, we talk about this idea of loss, which is basically how close are we to the source image. So that's this function. And then the discriminator basically allows us to look for the difference between the image that it gets and the image that it's expected to get. So it's sort of comparing these two images together and then looking at the loss as well. The optimizer is how fast the machine learning can go. I'm going through this really quickly because it's not a machine learning course. It's really about all the steps that we have to do. But basically we have to run all through these steps and just press play for all of them, and that should work. This is how it, so here you can see what's called the image generation step. This is kind of interesting. So it shows an input image, what it expects the image to be, and then a predicted image of what that image is going to be. I'm quickly going to see. Yeah, maybe I'll run another one. So this is the actual images that we'll see throughout the run. So, and because this is quite blurry, I want to see another one that's maybe a bit more useful to look at. Beautiful. All right, then we run this summary writer. We run a training step. So this is what the algorithm actually does. Again, very quickly, it generates an image. It discriminates the image, or basically looks at it and says, is it good or not? It does that for a real image and then for the generated output image, and then calculates the loss. So it says, okay, what do you think of this image, of the real image? Is it close enough? What do you think of this fake image? Is that close enough? And then it calculates which direction the machine algorithm, the machine learning, the network should take to make it better. And we print out these values as well. And we do this in a loop, basically. So once I run this function, this fit function, this will take a while because this will actually keep running in a loop to improve it better and better. And I will run it again. I will speed this up, but you can see how the progress improves over time. Here it's also important that if you have a faster CPU, so I'm using Colab Pro, then the machine learning will run way faster than if I use the normal Colab thing. So you can see in the output of which GPU that you get, but this one goes really quickly and the other ones goes a bit slower. So That's what you pay for, I guess. So let's wait for the first image to appear, and then I'll speed it up, and then you can see what comes out. So again, this is the image with nothing, so it hasn't trained anything, but now it's training behind the scenes. And then once all of these dots complete, so it's basically one row of dots, it generates another output image, so you can look at the result for that. So now we have our first image. This is actually after 1,000 steps, so 1K steps. And you can see it already picked up that the background's always the same color. I'm sort of have a face that's sort of in this direction. It's kind of confused with this part. I'm not sure what that is. It kind of has figured out that I have this sweater, and I'm always wearing the same sweater. And then as we go more and more steps, this will gradually improve until we get a result that hopefully is quite good. Okay, so it's a bit later now. This has been running for, I think, about 100,000 steps. It's not amazing yet, and that's, I think, because the input data is not amazing either. It's just using this crappy webcam. There's motion blur in it because some of the images are really unsharp as I move around, as we've seen. But it's, I guess, good enough for demonstration purposes. Also, what you notice that a lot of the subtlety in the skin is not captured here. That's also because the images are, in general, too blurry to be able to use. I think having like good input images is like step one. That's going to improve massively. Also, here it would help. Maybe we could try having the full resolution mesh as the input instead of this more schematic one. But this is nice because we can do different things with it that I'll show in a bit. So I'm going to stop here. So if I want to stop training, I can basically stop at any point here. I will get this keyboard interrupt, but this is fine. The model is still there. It's still in memory. If I want to see what the final result is, I can actually run this test image generation thing, which runs the image through the generator. Remember, this is now a new generator. And as you can see, before it was just random noise, but now we actually get an image there. So that's super nice. Yeah, still look a bit weird, but anyway. Then we have to save the checkpoint. This is really important because this actually saves the output of the model. If we refresh here, we can see an output checkpoints. This is basically the whole state of the model. So it's basically this model here. This is 655 megabytes. We could download this, including the index and the checkpoint. And then we'd have a model, both of the input and the output, to continue training. But I'm going to stop here because the only thing I need is a generator. I actually don't need the discriminator. In this part, I just need the generator part. So that's the part that I want. And I'm going to take this generator part out, which should now be in this generator folder, so this one. And unfortunately, we can't use this directly. We have to convert it, so I'll show you how to do that as well. So we're going to zip this generator in order to be able to download it. So that's going to be in our output folder. You can see it's making a temporary file here, and it's zipping up all of these files. And now we can download it. There's two ways to do this. One is actually the best way, and the other one is a bit slow. You would think the fastest way would be go here and to do download, and that's true, that works. The only problem is it's super slow for some reason, and I don't really know why, but this is really the case where this is super slow. So I mostly use the other way, where I actually mount my Google Drive and put it there in a folder. So this is what I'm going to do. I'm going to run this step. That's going to connect to Google Drive. It will open this little window here. Continue. Yeah, continue again. And then it will mount this drive here. I think you can see this. It's mounted under /drive. We don't see it here because it's like one level up. But the folder that I want, basically, so it's mounted at /drive, is basically drive, my drive, and then inside of there I can make a folder. So I'm going to call this Warsaw Workshop, and then I'm going to copy the generator into there. And this is important because my next script will actually pick this up, but it will be in the same folder, so I can just run it from there. All right, so these are all the steps that I have to do here. So now what I'm going to do is go to the runtime, disconnect and delete, so it doesn't keep running in the background. Yes. And I can open a new Google Colab script here. So I can go to File, New Notebook. Sorry for the bright white light here. Let it do its thing for a bit. And then can we actually import upload notebook? And then here we go to GitHub again. These maybe should be populated. Otherwise, we can just copy and paste this link. I have to press this a couple of times in order for it to work, and then still it's a bit weird that it's on the wrong one. But the one that I want is here, training Colab, convert to TF.js. This is the file that I want. So I'm gonna say leave page. It's gonna open a new Colab. And this is a script that actually takes this generator that we made and then converts that to the format that we can use within Figment. So again, we run all the cells here. We run play, we ask run anyway. This is going to install TensorFlow.js, this JavaScript library, this Python JavaScript library that has these conversion functions. Now I have to warn you, it's a bit unstable. Sometimes it works, sometimes it doesn't. They make these changes to the library, and sometimes that makes it not work for some reason. So we'll see how far we can go. Then we mount our drive again. Again, we could upload it here. So these is explained. Yeah. So I have connected my drive here. I could also upload my own model again from the sidebar and then drag my generator.zip inside of there. But now I'm going to mount it. Here it's important to match the folder that I have with the one that I want. So Russia, because I know that's going to be in there. Oh yeah, and here it says I have some helper functions. I actually should run this cell as well. It's kind of hidden. Okay, cool. So I don't have to do this. This is a pre-trained generator model. I don't want to run this. I want these other steps. So now I'm going to unzip this model. Again, that will show up here in the generator. So these are all the files for the generator. That's cool. And then I can run the TensorFlow.js converter. So this is the main script. Beautiful. And oh yeah, sorry, I missed one here. So I have to run this output one, and then I can run the main script here. There will be a lot of output that's sort of annoying and maybe not super important. It says here, I don't run on GPU. That's fine. You can run on the CPU as well. So now it has actually created this zip file for me, which is here in this output folder. It's called tfjs.zip, and this is the one we actually want to download. So we can run this last cell that's just prepared to do that. And that's going to just download this file. Again, this might take a while, but this is a highly compressed file. This is the one that we need. So I'll speed this up and then we can work with this file again. It's finished downloading. I can show it here. I'll put it here on the desktop, and then I can unzip it, and that's going to be this tf.js folder. And there's just a bunch of files in here, and then there's this model.json inside. These are basically all the weights of the model. All right. And now what do we do with this? Now, because this is a thing in Figment, we actually have a node for this. And the node that we want to use is this one, which is image to image model. And it's kind of difficult to find because there's this sorting thing, but it's this one. So this runs a generative model. Now it's a good practice to save our Figment files first. So both are in the same folder. So I'll make a folder on the desktop called face installation, a file with the same name, and then I'm hopefully can see this folder somewhere on my desktop. One sec. So this one, and then I want to drag this tf.js folder inside of there. And the reason is because once this file is saved, now if we open this, it will have a relative path instead of an absolute path. Now, this image-to-image model, what it requires is an image in the same size as our training image, so basically 512 by 512. Oh, we have one here, so we can drag this in, but it's going to be super weird because this is not the input that it's expecting. So you can kind of see the background, maybe, but it's not reacting to anything. Remember, what we want is we want the input of the image. So we have our webcam image. It's me again. We go to our resize node, and then we can drag that in. But again, that's also not really what we want, though it does have some effect, but it's not really the input that we're looking for. Actually, let's rotate the webcam image. So let's flip it on its head. So we're going to transform this, drag it in, and then here for the scale X, we're going to type -1 to flip it. And that's going to make it a bit more easier for me. Why does this work? Well, because the training data, the input data that the model got was the actual face detect. So this is what we have to put in. We go from here to resize. We have our detect face, exactly the same that is set up. And now we can actually have our model basically work the way that we expect. And you see it's pretty accurate. And it's kind of creepy and scary. And then let's stack these two together. Why not? And then we can look at the output here of what the model generates versus what I look like. And it's kind of, yeah, you can see it's not perfect yet, but it's getting there. It's kind of crazy. So this is the basic workflow of using machine learning. But the nice thing is that there's a bunch of other things that you can try here. So we don't actually have to start working from this detect faces. We can put whatever in that we want. For example, we could do a transform here and then basically play around with the input that we give to the model. So let's do this. And then let's start, for example, rotating this image and seeing what happens. So you get these really weird translations that can happen on this model. And again, because the system will generate an image regardless, it's just maybe not the exact image that we want. So we can start scaling or doing all kinds of weird things. And at some point it will break down because the images are too big or too small for it to work. But there's a lot of fun to be had with these images that we can do. Another thing that we can do as well is we could mirror this image. So we could take this transformed image, mirror it. Now we have two. Let's change the angle all the way around so it looks like this. So -90 degrees. Do that, and then it still sort of works. It still gives this really weird image. Let's rotate this back to 0. Let's rotate this to 90. And now we have like two faces here. And again, it sort of works because the input sort of relates to the output. The model doesn't really care that it's now two faces versus one face. It still does it. It still tries its best to make a model that works. But you can do all kinds of interesting stuff with this, just feeding it in different things than what the model was actually trained for or expecting. Again, if we want to show this in an installation context, we might use a resize node here at the end and set that resize to the size of our screen. So for example, if we have like a normal full HD screen, we would do something like this. Maybe set this to contain, to have like a little black border around it. Drag that to the out, and now if you do full screen, we basically get an installation of our crazy face that we can use. All right, don't forget to save your network, and that's it. I'll see you in the next one.